Hello children, welcome back. Now I'm doing 8th class Telangana state syllabus, first chapter, rational numbers. Before going to this rational numbers, let us talk about the property practice what you preach. Practice what you preach. Children, preaching means what? Preaching means what is good, what is bad. Explaining others, or you are giving suggestion to the others, be like this, be like that, do good, do the things which are beneficial to the others, don't do this. These are all things which we are saying to the others. These are all nothing but the preachings. But the thing is, observe yourself. Are you really practicing what you are preaching? That is very important, children. When you say a word, when you utter a word, that should hit the other's soul. That is possible only when your voice has a certain weight. When will it has weight? When you really practice it. Because when you practice what you are preaching, your personal experience will add some weight to your words because you have experienced that. So, with that, when you preach, definitely that will change the people and that will change the society ultimately. So, you will be living in a healthy and happy society. This is what we all need it. Now, let us come to the topic which we are doing, closure property. Closure property we are doing in rational numbers properties. In the previous class, I have discussed the first part of closure property. Closure property of natural numbers I have taught. I told you that you have got closure property for natural numbers, whole numbers, integers, and rational numbers. And in this also, for every property, every closure property, you have to talk about under additions, under subtractions, under multiplications, under division. Whether that closure property is suitable for that number system, that you should know, children. If you have this knowledge, you can proceed with your exercise sums. So let me explain you this closure property under whole numbers. So first we will be talking about under addition. What is the closure property under addition? So, what is this, children? If A and B are two whole numbers, two whole numbers, then A plus B is equal to a whole number. This is the definition, children, for closure property under addition. So, let us take A is equal to 2 and B is equal to 5. Now, what is A plus B, children? A plus B is 2 plus 5. 2 plus 5. That means how much, children? 7. So, 7 is a whole number. 7 is a whole number. Therefore, whole numbers, you can write like this. Whole numbers are closed under addition. Means what, children? Yesterday I have given you the definition. Closure property exists. Either you can say like that or you can say like this also. Whole numbers are closed under addition. This is about closure property under addition. Copy this, children. Now we are going to do under subtraction. Closure property under subtraction. So here also the same definition, children, but instead of plus you will write minus. If A and B are two whole numbers, then A minus B is a whole number. So if A is equal to 5, B 2, B is equal to 5, what is A minus B, children? A minus B is 2 minus 5. What is 2 minus 5? 2 minus 5 is minus 3. What is minus 3, children? Minus 3 is not. Minus 3 is not a whole number. It is an integer. So we will say that closure whole numbers are not closed. They are not closed under subtraction. Whole numbers are not closed under subtraction. So there is no closure property for subtraction, because see, if you take A as 5 and B as 2, of course 5 minus 2 is 3. You are getting whole number. But in other way, if I take, I am not getting. That means what? Closure property exists only for a few numbers of whole numbers, not for all. In that case, you cannot say that closure property exists. So we will say that whole numbers are not closed under subtraction. Copy this, children. Now, we will be dealing with under multiplication. So, everywhere you need to change it as multiplication. So, let us see under multiplication. So, same property. What is the property says? If A and B are two whole numbers, then A into B should be a whole number. If A is equal to 2, B is equal to 5, A into B should be equal to 2 into 5. How much 2 is 5, sir? 10. So, what is 10, children? 10 is a whole number. So, we will say that whole numbers are closed. Whole numbers are closed. Are closed under multiplication. Whole numbers are closed under multiplication. So there is closure property exists for multiplication for whole numbers, because anyway you take, children, A into B or B into A, you are getting the same positive values only under any circumstances. In case if you take 0, if A is 2 and B is 0, 2 into 0 is 0, 0 is also present in whole numbers. So you will be say that, you can say that whole numbers are closed under multiplication. Now we have done additions, we have done subtractions, we have done multiplications. Now we have to go for divisions. Under divisions, if A and B are two whole numbers, then A divided by B should be a whole number. So when you say that 2 divided by 2, A is 2, B is 5, you will write 2 divided by 5. 2 divided by 5, you will write it as 2 by 5. What is this 2 by 5, children? 2 by 5 is not a whole number. It's a rational number. So we will say that closure numbers, that is whole numbers, are not closed under division. So they are not closed under divisions, because whole numbers, when you are dividing, you are getting rational numbers. So it is not there, children. So the 4 properties I have taught for whole numbers, that is addition, subtraction, multiplication and division. We found that closure property exists in addition, closure property exists in multiplication. But what about subtraction? It is not. For division, it is not. So we'll prepare a small table for it. First you copy this. Now, just like yesterday, what we have prepared a table, like that we are going to prepare a table for whole numbers here. So whole numbers. So these whole numbers we are going to talk about under addition. Okay, children. Next, under subtraction and under multiplication. Next, the place may not be sufficient, children, so I have to write little bit nearby. So let me write here. So whole numbers, addition and subtraction, multiplication, division. Okay, children. Now let us see how are these whole numbers are dealing with additions, subtractions, multiplications and divisions. This is what I have taught in your natural numbers also. I have done the same thing. So the same thing I am doing it here also. Additions, whole numbers are closed. Subtractions, they are not closed. In multiplication, they are closed. In division, they are not closed. So this is the table that you will be getting for whole numbers, children. Copy it. Now, I will be dealing with integers. We are going to talk about integers. When you are talking about integers, again integers, you are having, for integers are the same definition if A and B. First under addition. First I'll write this. The first part is under addition. What is the definition you will be getting? If A and B are two integers, then what you are getting? A plus B should be an integer. So, for example, we will take A as 2 and B as 3. So, what is A plus minus 3 I'll take because in integers, no, so 1 minus 1 plus. A plus B can be written as 2 plus of minus 3. You know that, children, when two signs are there, you have to put it in bracket. That means for children, 2 minus 3 means minus 1. Minus 1 is an integer, no? Minus 1 is an integer. So, since minus 1 is an integer, we will be saying that integers are closed under addition. This is the property, children, for additions. Integers, if you add, you are going to get A. Whether you get plus or minus, whatever it is, minus values are also there in integers. So we'll be saying that integers are closed under addition. Now, we are going to talk about subtraction. Integers under subtraction. So in this subtraction, if a and b are two integers, then a minus b should be an integer. So a is 2, b is 3, minus 3, a minus b is 2 minus of minus 3. It will be 2 plus 3. 2 plus 3 is 5. 5 is an integer. So integers are closed under subtraction. So even in subtractions, you are having closure property for integers. So integers are closed under subtraction. Copy this, children. Now we will go to the multiplication. Under multiplication, if a and b are two integers, then a into b is an integer. That means a into b is 2 into minus 3. What is the value of 2 into minus 3? 2 3s are 6. First you will multiply sign. Minus plus into minus minus 6. So minus 6 is an integer. So definitely integers are closed under multiplication. Okay, children. Integers are closed under multiplication. Copy. Next, we will go for division. Under division. If a and b are two integers, then a divided by b is an integer. If a is 2, b is minus 3, a divided by b is 2 divided by minus 3. How will you write, children? 2 by minus 3, that is minus 2 by 3 you will be writing. Minus 2 by 3 you will be writing. So, is it an integer, children? Minus 2 by 3 is not an integer. It is not an integer, children, because it is a rational number. So integers are not closed under, what is that? Under division. Integers are not closed under division. Write down this, children. Now again, we will be having the table form. That is, you are talking about addition, you are talking about subtraction and multiplication and division of integers. We are talking about integers. So this is the table we are making, children. So under additions, under subtractions, under multiplication, under division. Under addition, integers are there. Under subtraction also, integers are there. Under multiplication, they are there. But under division, no property exists. Closure property does not exist under a division. I hope you have followed me, children. With this, I'll stop today's class. Next class, I'll be doing in the next class.